Hey guys, thanks for coming.
You in? Good morning.
This is Glen. He's actually going to take us through the operation of the printer here. Just show you what you can actually do. Jeff. Yeah. Jeff's actually renovated one that we got given for scrap. So Graham. He's got it going. Graham, sorry. He's got it up and running, so we will have a 3D printer in the man shed, so open to everybody to use. I'm sure you'll get a lot out of this. He's also bought samples, of course, of different gear that you can use or make on the machine. I've got no idea how it works, so it's going to be a bit of an experience for me. So this is Glen, guys. It's Tim's brother, Tim from the metalwork area.
You're right. Yep, cool. Thank you.
He's better looking than you.
So, guys, yeah. So I'll just mention. First up, I came in about a month ago to talk to meet Andy, and Tim introduced me to Andy. We were talking about when would be a good time for me to come in and do a talk. And they said, well, I said, look, probably 10 o'clock, how does that sound? And they said, well, thing is with that, the guys have just finished Smoko, they've been smashing Tim Tams, they're full of sugar, they're out of control at that point. So we don't know how they're going to go. All right, so here we are anyway. So I'm sort of braced myself, but you look pretty calm and you're receptive, so we look safe. Okay, so I'm just a bit of background for myself. I don't confess to be an expert on this stuff. I've been playing with it for about 5 years. I wanted to get good at CAD drawing. So my background is I'm a TAFE teacher. I'm a boilermaker. I teach my trade at TAFE. And my experience is like 20 years using AutoCAD and cutting out, as fabricators, metal fabricators, we cut out flat shapes on laser cutters, plasma cutters, that sort of thing. And then we form them and bend them and roll them into 3D objects, you know. So, but 3D CAD, like this next level jump for me, which was quite a hell of a jump. It's been quite a challenge. I wanted the 3D printer so that as I'm building my CAD experience, my CAD knowledge gets better and my experience gets better, I can print something and go, right, what's the next step? What's the next step? What's the next step? And that was my approach for why I picked up 3D printing. And I thought it was going to be a case of press a button and should be right, let's just go. And it's not. And like 3D CAD's an animal to learn, so is the actual 3D printing as well itself. They've both got their challenges and you've got to be prepared to put the effort in. Having said that, things are getting better and easier to use with the technology improvements. When I started, I think it was about 2019 when I started, and trying to find information on how to manage challenges on more of a manual machine like the old Flash Forge that Graham's got up and running. All right, that old machine down there in the corner. That's much more of a manual machine where you would manually set, you'd have like a bit of paper as a feeler gauge and you're trying to get the head right and all this sort of thing. Now you'll see this thing, and this is dated, but this goes through and it does these automatic settings and tells you that the bed level looks pretty good, everything's calibrated right, let's go. But it still gives you problems. So I'm going to talk about how I got in, but also just where what it's taken me to get to this point. But also, if you guys wanted to buy a machine for the men's shed or as individuals, what I would suggest and recommend, I went online. I didn't know anyone in Perth who was doing it really, so there's a few people doing it. I found a guy later who I'm going to suggest. Don't go online, go to Belmont. All right, there's a guy there, he's got a little shop and he's awesome, he's brilliant. And he'll hold your hand, you buy the stuff through him, you buy the machine through him, and I'll recommend this make of machine, the Prusa. All right, I'll mention that. So, as I said, I'm at TAFE, I'm off work, and I've been off work for a year. I've got a little bit of bowel cancer, but we're pretty much on the best side of it now. And that's what gives me the time, gives me the ability to be able to then talk and give some time back to you guys today. So, that in mind, I'm going to start the print early because it's a 40-minute print. There's one thing we're going to do. And Tim, do you want to just send the geckos around? This is what we're going to print. Everyone take a gecko if you'd like one. And you can actually see the layers. I'll talk a little bit about what we're printing as we go. It's only a 40-minute print. It's a slow process. It's a slow process, but I'll talk you through it. So let me get it going, and I'll talk you through it. By the way, I'm shooting this video. I'm recording this so that other men's sheds might want to use it. You guys might want to refer back to it. I can also use it because other people have asked about this sort of information, so I can actually use this video to put on YouTube. You guys can access it if you want later when I get around to editing, and I do that sort of stuff and I mess around with it. So when I get a chance, I'll do that. Tim will let you know when it's ready. Just nag me if it's been a month and I still haven't done it. So I put this is the basic setup with the filament holder, holds the filament in place, and I just run off the filament. Now I've got a different setup at home. I run my system through dryers and so forth, which I'll talk about later. I'll let me get it running, and I'll talk you through as I'm getting it running. So the power on button at the back here, have a bit of drink of water as I get a bit dry. And yeah, that's it, thanks Tim. Now, we'll print the one single Geko. This plate comes off. This is the build plate. It's a metal flexible build plate. And generally I run a isopropyl alcohol each time I do a print. I spray it. I use like a kitchen napkin paper towel, just to, because it's got no perfumes or smelly bits in it which add oils to the base plate. So I'll put that in position. Got little magnets on the bed so that as it snaps on, it just grabs it on this type of machine. Some, like the old one there, the old school machine, that uses it as a glue. You have to use a glue stick to stick the stuff down. This has got a heating element which runs through and heats up the bed so that this plate will run up to about a temperature of about 50 to 60 degrees. That helps with adhesion as you do the print. It like squishes and pushes into the plate to help get it stick for that first layer so it doesn't come apart. It doesn't pull away, which it does now and again, and when you do, you come back 6 hours later and you've got spaghetti everywhere. And you do come across those issues, and it happens, but you just push through. There's nothing perfect about this. It doesn't, you never walk away from the machine and just, yep, she's good. You always wait and check, make sure the first layer has worked and it's stuck properly and it's good. You've got a bit of confidence right now, walk away. Right, so I've noticed I've got a bit of cable out. I wanted to just show you, I could have left the cable connected. The polylactic acid, PLA filament. This is the most basic out of all of your filaments. It's the easiest to print with. It's like the plasticine of the plastic world when it comes to 3D printing. So, and I haven't gone technical. I was talking to Brian earlier. We've got some of his stuff. He's done a TPU, a flexible filament. I'm still playing in the sandpit. I haven't progressed to swinging off the monkey bars yet. All right, I'm just playing to get my ability right so that my CAD drawing gets better. That's my goal in this. So I use this for models for where I've say, I'm on the press brake at work, I want to bend up a certain shape, I want to check that it fits in where I want it. I'll 3D print this first sometimes and just check, yeah, that bend works quite nicely. It's a really tight bend, I can make it work on the press. So then I'll print it, but I'll just check it, and then I'll use it for examples how I could use it. Okay, so there's that ready to go, that filament. I'm going to heat this build plate, excuse me, while I jump in front. And I'm looking for unload filament, PLA, yes, it's heating up now. So I'm going to heat up the hot end to about 220 degrees, and I'm heating up the build plate to about 60. And then it's ready, it'll beep, tells me to press the button, pull out the old one, running the new one. So the hot end, and again, I'm going to break down this information a bit more later on, but at the moment, you'll see this little box at the front's an extruder motor. What happens is, as I do, the filament starts coming through, I press it, and the extruder, little gears inside start dragging and pulling, gripping the plastic and dragging it through the hot end and squishing it through to make it do the print. Have you ever seen on television that when they 3D print houses? And they've got the concrete running along and building the walls. That's the concrete getting layered. It looks exactly the same, but you need a magnifying glass to see the same process happening here. The plastic gets melted and it just does this squish, right? And it builds the shape. Whatever you've created, it will follow that and build it. And I'll talk again, and I will talk a bit about that in detail, but I'll just get the print going first. So the extruder motor grabs the little gears inside, grab and pull the filament down. Old school, like that one, I think, I can't remember that one, I've got another one, old school one I'll show a picture of. So press the button, get rid of the old filament, take it out. Now I'm going to set it and bring the new filament in. Load filament, yes. Press the button, the gears start spinning. I push the filament in. I'm putting my finger on it and I can feel it. Yes, it's running because it's hard to see it at times, but I can feel it dragging through. It's going to say to me, are you happy with it? Which is asked me, no, I'm not. I can't see it coming out enough yet, so I'm going to go again. No, I'm not happy. And then it just does a little purge. Then it'll ask me, yes, I'm happy. Good. Print from SD card. It's a smooth sheet. Print from SD. Geko, yes. And now it's just going to get it ready. Now what I'll do is I'll wait till it starts moving. There we go. And then I'm going to just use a little wire brush and take that little boogery bit off the end. Drop it in there. That's my scrap. And what it's going to do now is it's going to go along and it's going to find 9 points on the bed and set itself and calibrate itself in relation to the hot end to the bed. Come and grab this seat, mate. Drag it over there. And at any point, if you want to come and have a look, well, I can talk underwater. So just come and have a look. If you want to come closer and have a look at the process while it's happening, feel free to just come in. Now it's running up to the front. It's going to do a little purge line. It's bleeding a bit out to just to make it flow nice. And then it moves, and then it will start the outer layer of the Geko. And then we'll start building the Geko. And it goes up at 0.2 of a layer, so 0.2 of a millimetre. So it'll put 0.2, do the whole print at that level at 0.2, move up, print another layer at 0.2, move up, print another layer at 0.2 until it's built the whole job. And that little Geko, if you don't have one, again, the guys, there's more around, there's heaps of them here, that you can have a look at the Geko on the side view, you can see the layers. And that's the 0.2 layers going up like that. With each little build, each run for the machine. Inside, you can set the infill to actually how dense you want it. Do you want 100%, so you could drill and tap a hole into plastic? Or do you want it at 50 or 30% just to keep it light? Excuse me. And there's all different, yeah. Anyway, right, so on your LCD display, what I'm seeing here, I'm running at 215 for the hot end. The hot end, as I said, is hidden inside, and I'll show you that, what it looks like in a minute, up inside behind the extruder motor. I've got 0.2 Z height, so X distance, Y distance, Z distance is how 3D patterns work. On the bed, we've got 60 degrees. The SD card in this photo, I did this one last night just as doing a practice run to make sure everything was going right. I took it at, well, there was 66% into the print, 37 minutes left on the print. PLA, and this moves because it's got a lot of information in it. That's the Gcode, which I'll talk about that later. 39 minutes left in the print. So, and if I go there now, and I've got 39 minutes, we're at the same point as what that photo pretty much says. Next slide, would you, Tim? Summary on this. Filament spool is polylactic acid, PLA, the most. And the guys, this is, Andy's got a copy of this slideshow on email. If you want it, just hit him up with an email and he'll send one out to you. If you've got any questions, hit me up down here. Feel free, oh, it's cool. So the bed temp, hot end temp, layer height 0.2. Next one, Tim. How STL files are created, how Gcode is created. Next one, please, Tim. So, an ST file, we need an ST file to, and don't worry about all the high-tech sounding terminology, it's just pretty basic info really, but go deep, it's in complex, but interact with it on the surface, it's not too hard. The STL file is created by using either a 3D scanner, they can take a photo of this drink bottle or the truck or whatever, take a photo of it from different angles, 360, That gets imported into some software. Don't ask me any, and then they generate the information there, but I've never done it. I was doing this for 3D, for my 3D CAD skills. That's why I got into it. I've never done any scanning. The guys at TAFE in the machine shop do a lot of it. They 3D scan images and then they bring them in and they play with them for their machining, for their CNC machines. Like a boss or like an internal thread and external and all that, and how the pins are going to line up, whatever. But that's out of my depth of knowledge. So through a 3D scanner, we can generate a G-code. Next one, Tim. Or a 3D model, and that's me. This is where I've played. So I drew this up. This so an STL file can be created from a 3D model, and that's the 3D model that I made here of that, which I drew up. I'll explain about that a little bit more down the track as we go in. Next one, Tim. Then we've created something, and that, sorry, I've been at it for a couple of years now, and I'm getting better at it, but AutoCAD's my baby because I'm being a fabricator. I pull flat, as I said, I pulled flat sheets of metal out of a rack. I cut them into shape, then I form them and roll them and bend them into shape. But it'd be nice to know the 3D stuff, but as I said, it's quite challenging and I'm getting there slowly. So that's the software it's created. It's created the model. Then from the model, I export from that model, next one, Tim, into my slicing software. Talking to Graham or Brian, I think you guys use Cura software. Yep, Graham uses Cura. And Cura, it doesn't matter. These softwares are secondary software. So what happens is you've created that model in the drawing or scanned it or wherever. You bring the model into this other little environment through another software. And then, in this case, I made this. Now, I could have printed that straight off the bed, but I've got issues where what happens, this can't just print into nowhere. It's got to have something to hold it up. Imagine me standing here and being the slim person that I am, all right? But my belly hanging over my belt buckle, I've got to have some support running from the ground up to support my belly, my chin, my nose. If I was to put my arms out, even more complex, they have to be held up with stuff that looks like cobwebs, all right? Just to hold it in position. So I had to tilt this on an angle, bang, to then create, next slide, mate, and then to select the support to be able to print it in that position. That becomes waste that you just break off. And if I look on the side here where that's sat, I've got a bit of a gnarly sort of a feel to that edge here, and the back side where that support material sat, which I broke off to give me my model. All right? This all comes with experience. Like I said, you start with the basic shapes and you build up. While we're on the, if I printed this as it is, no problem. It would print that, start with a good solid base, work its way up, taper off. If I turn that bottle upside down, then I've got problems. I've got to now have support. And it would do something like that if I was to put that support into the software and wanted that printed. And if I didn't have the lid on, even more complex, because that software, that support's going to run up inside the cylinder, and how am I going to get it out? So you have all sorts of issues, and I found, well, and again, these are the things that you build on with your knowledge. As you know, after 5 years at it now, or coming up to 5 years, I get a bit gooder at it, and I lay it over a little in a 45, and I can find I can get the support that way. This one would probably be worse because it's got more of a sharper angle up, so therefore it's going to be a lot more aggressive support required for that. So that's the support, one aspect of inside playing with the slicing software. I bring the model in, I've got the STL in there. I'm going to generate the G-code out of this so that the tool path, the tool head can follow this and follow its pattern to create what I want it to create. All right? So, next slide, Tim. Sorry, go back one again. Sorry, mate. If we go here, have a look at this side here. This is the information. I press a button. I say I've selected what I want in here. I press the button, and then I generate. And because now we'll go to the next slide. Now this will show you this top right-hand window what we were just looking at. I've selected a 0.2. I could adjust this to I want 0.4. I'll get I won't get as a refined finish. 0.2, but I always get a better result for a 0.2 layer. generic PLA, if I have a specific product I can put it in. I can change the different filament types, all right? Filament PLA, the next one I use is PETG. They're the two that I play with, that's it. And talking to what Brian's done here with this little truck, come and have a look at this. Is quite impressive what he's done here. Have a look at the suspension underneath. This shows you the flexible TPU filament he plays with. And this is PETG here, so it's a bit more structurally capable than the PLA. And this is the TPU's flexible filament, which I haven't played with. I've had someone print something for me on it, but I'm not set up for it. Again, back to my CAD. I'm concentrating on CAD with the idea that down the track I want to be like Brian one day. I want to actually be able to print TPUs and things. All right. Organise support we talked about. Do I want support? Turn it on or off. Do I want a brim? A brim is that little goanna, that little gecko around his feet. You'll probably see it in another image. You'll see this extra pad layer. That's to help the bonding in that first layer, because if you don't, if it shifts and moves, you've lost it and you've got this spaghetti everywhere. So the brim is actually on or off. That gives you extra bite into the bed so that the print can stick. And I've got a 30% infill. I could change it 100% if I want. Down to the bottom of that same side of the screen, we've got, this is sizes. You could change that from 100% to 120 to increase the size, scale up the print, make it bigger. You make a big gecko as big as it'll fit on that plate if you want, just by changing the size. Well, I don't generally look at the stuff, but if you want to go break it down, gives you the actual measurements, the scale of the size. Uses 4.8 grams of filament and how much volume of filament. Cost is 0.15 cents. What they base that off, I don't know. I never programmed anything into that. Maybe they just got a generic sort of allowance that they've worked off. And the time. That's why I always look at the time. 39 minutes. Excuse me. You happy with that? Yes. Export the Gcode. Bang. Done. Export the Gcode. It'll generate the Gcode file for you, which is what I put onto an SD card, which now sits into the machine and what the machine's reading to do the print. Next one, Tim. Again, summary. Import the STL file from the slicing software. Select the supports if needed and other changes. Select the filament type, export the Gcode, insert SD card, and then for the print, yep. This is the hot end of what it looks like, and it's inside, as I said, behind, hidden in there, you can't see it. But basically the filament comes down into here, runs through the heat break, and you'll see that heat sink sort of set up, and you see all the guys pulling the computers apart, all those heat sinks that are in there. It does a similar purpose, just made of aluminium. Aluminium's a good conductor of heat, so it sort of dissipates quickly through it. Little fins so that as the fans on the side run, they run air through those little, to take the heat away out of the plastics. But the fan generates the flow through here without affecting the heat block. This creates the heat through here. Next one, Tim. And here's the nozzle on the bottom. This is the heat block or the thermistor, and that's what controls all your temperatures through these major wires. And then the nozzle. And the plastic comes out of the end of that nozzle, which is the next slide, Tim. And that's at 0.4 of a diameter of your, so the whole of that nozzle comes out, the plastic comes at 0.4 of a diameter, and this is 1.7 mil in diameter is your filament diameter. You get different, but that's pretty the bog stock sizes that you traditionally run with. Just checking. Looking okay. And again, like I said, guys, feel free. If you want to, at any point, just come and have a look at it. If you want to see what's going on, knock yourself out. Next one, mate. Yep. Okay, fused deposition modelling, FDM printers versus resin printers. Two types of printing. This one is this one I'm using. This one, Tim, we go to the next slide. So this is a resin printer. I'll send these around. So this is a well-known little test print called a Benchy. It's a little tugboat, and basically that's it there. And it's probably the most famous, one of the most famous test prints for 3D printing. And it checks, because there's different angles it has to achieve. It's got issues bridging across. It's got little test angles and so forth in it. That's the FDM, what we're doing. If you just send them around, and this is the resin print. This is a guy at work did this one. This is resin. It gives you a nice, cleaner finish look to it. Good for little, like little figurines and things and stuff like that, but not as structurally capable as the FDM. Excuse me. Like the resin the woodworking guys would use to fill up gum veins and things in tables. It's a similar type of resin. And it sits in this vat, and what happens is the build plate pulls out slowly and a laser light goes in and just shoots and dries out off all the bits that it wants to keep and lets all the rest of it flow off. Don't ask me how it works, anything other than that. I'm sticking to FDM, that's what all I do. I don't go to resin. I can't be, it's too fiddly and messy and I'm not interested. So FDM for me, that's it. Next one, Tim. So that's the FDM process. It's a bit more open, this image, so it just shows you the same thing, but it's different machines. It just shows you what's going on. Hot end creating this shape. Graham, you did that little test print, didn't you? You did a similar to our test tower. These are good little tests to do as you get into it to see what temperatures, and you can set it up in the machine where the Gcode at certain levels, and you can alter all this. When you get a little bit more advanced, you alter these Gcode temperatures and so forth. And how, so that's running at 240, 235 up to 190. And what sort of effect it has on the overhang, how much stringing do you get? I'll talk about stringing a bit in a minute. But that just shows you performance. And you look at it and you think, this is where you can see it ain't a case of just press a button and she'll be right. But having said that, things are getting easier because of the machine. In a comparison I'll draw, my brother-in-law said to me once, Glenn, if you want to get fit, you get an old push bike and then you get right on that rather than the new one, because the new one you can lift up with a little finger. The old one's like, you got to lift it like this, you're going to get a better workout. Yeah, but who's going to want to ride a push bike made of steam pipe every day? Do you know what I mean? But if you've got a little racehorse, that you'll jump on it and you'll be on it every day. So I think, unless you're a bit weird, a bit like me and Graham, maybe you like pulling things apart and going back and looking at old things, but you really do, if you can prepare to do that, you get a good understanding of the new stuff, so that when you come to the new stuff, it's easier. But my suggestion is just jump to the new one. If you're interested in this, and especially as the men's shed's interested, go to the newer stuff. And the support we have here in Belmont, I'll tell you about that again, but it really is, makes life a lot easier. Okay, next one, Tim. 3D printing welding, as I said, I teach welding. I think there's a lot of comparisons between, in welding, when I'm talking about welding, I'm talking about gas metal arc, MIG welding. Not stick welding so much, but MIG welding. If you look at a MIG welding machine, and those of who play with it, or if you don't, go and have a look at the MIG welder down there. Open up the flap on the side, look at where the spool of wire runs off, look how it runs through the rollers, look how it then goes over into the, runs down the liner, into a gas diffuser, into a copper contact tip with a shroud that protects the weld zone from the atmosphere. And if you look at this, you've got the spool coming off, the wire going through the extruder dragging it down into the hot end where it does its deposit. The biggest enemy in welding is oxygen entering the weld zone. We've got to keep the oxygen out of the weld zone for welding. The biggest enemy for 3D printing is moisture. We've got to keep the moisture out, but both of them are interreacted. Both of them cause the same problem, and they interact with each other. In welding, if I had certain metals, when I weld in structural stuff for mining and that heavier type work, I've got to keep all my electrode wire and electrodes dry. They have to be held at certain temperatures to keep moisture out, because otherwise I'm going to introduce hydrogen into the deposit into the weld zone, which infuses cracks in the weld zone from hydrogen assisted cold cracking, but I won't go into detail about that. But the actual problem with 3D printing is we have this stringing issue where moisture gets into the plastic and we get this really terrible looking print from the moisture in the plastic. We've got to keep the moisture out. That, as well as those other little things about how the system works, how it runs through the liner. Next one, Tim, thanks. An example of that is, here's my old, Norm's had the Ender Cubic. I've got, this was my old one. I had when I started, and just what a can of worms it was for the old one compared to this Prusa. They look similar, but they were just totally different. I didn't want to spend $1,500 to get started. I spent $400, and I reckon I spent that many nights on YouTube and Google trying to work out all the issues. In here, it's different, and these are still used this day and age. There's a different, when I talked about the extruder motor right here, this drags the filament down. That's such an advantage for plastics which are not stiff, they're flexible. So I had to use this extruder here, which then pushes up through this Bowden tube, then directs it down onto the print. Whereas here, it's right down, it drags it onto the print. Now, that's an advantage. The only disadvantage is there's more weight here on the gantry, which can put into them. But for what I've seen in my compare the machines, there's no disadvantage. This is so much better. This system is so much easier, less problematic. Again, if I compare it to welding, if I weld aluminium, a soft metal, I'm trying to push it up through a liner. When I weld aluminium, I actually use a push-pull system. So I have a push down here, and I have a pull at the handpiece with some rollers at the handpiece that drag the wire up because it's so soft. And because this is soft, I'm right here, the extruder's right here where it drags it through the hot end right at the point where I need it, where it gives such an advantage. Next one, Tim. So this is my setup at home, this is my printer, and what I've got, when I was welding on site, in some jobs, inspectors would walk around and make sure my welding electrodes were in an oven, at a hot box, kept it so the moisture couldn't get into those electrodes. I'm doing something similar here. I'm pre-drying all of my filament that I'm going to use. So I pre-dry it, I keep the moisture out of it. I move the spool of wire of filament into my other dryer. As I start the print, it comes out of a hot box and it keeps that moisture out. So the moisture's got no chance of getting in. And my first year of printing, I didn't understand this. I had this big problem of stringing, which you'll see an image of shortly. As soon as I got onto this and understood it, the whole thing just changed for me. I just went from 0 to 50 overnight. Okay, next one, Tim. Another image of that's just the iBoss dryer, which I've got. I can put 2 spools in to dry it out. Yep. Next one. Another view of just how this one works. You can actually set that up to pull straight out of that, but I found it wasn't easy. I had to build too many little 3D print, too many little things to make it all work. So I just got these 2 different setups. So that was the best thing for me. Yep. Next one, mate. There's a stringing problem. That's what it looks like if you get moisture. You have moisture inside your filament. You don't dry it out. They're the issues you have. So drying out your filament is just the first big step and getting a good result. Yep. Another thing I go to is you can send that one around, Tim. You've got that little sort of thread on that. I got this off what they call Thingiverse. I'll talk about that in a minute. A little gel jar that I put my gel in. I've got a colour change gel. So when there's moisture in it, it's red. Then I know I've got to dry it out. I'll put it through a food dehydrator I've got set up. And it brings it back to blue. Then it's good. I know that's dry again. I'll put it in my box. Next slide. Oh, sorry, here, Tim, it's all right. Then I put these little gel boxes in here. Close the lid. Little boxes I got from IKEA. And then I just keep my filament dry. So for my next print, I'm sort of ready to go without having to run it through the pre-dryer. Yep. Thingiverse. Thingiverse is a website you can go to for free STL files. You want to print anything, they've got anything on there. And to start learning how to print, go to Thingiverse, play with it, download. You've got to then learn how to, do I need supports or don't I need supports? And there's a lot to learn. So you download your STL files, don't cost you anything, and then you're away, you can get stuff to start printing. I suggest it, I use it now and again. I got that jar off it, it was fantastic. Next one, Tim. So here's an example of a toothbrush holder. So you choose whichever one you want, okay? I like the look of this one, I'll download that. Now look at the problem I'm gonna have here straight away with this. It looks cool and you just think, oh yeah, I like the look of that, I'll print that. How are you gonna go with your supports? your support's going to be in place. You're going to have to just, and this is where you just got to jump in and play and be prepared to make mistakes. It's just not, it sounds all simple, but when you get in there and play with it, then you pick up the skills and you get the knowledge and you just get better at it as the more you play. Okay, next one. You will get to a point where, if you do get into this and you want to play with it more, you'll get to a point where your Thingiverse is not enough, and you're going to want to pick up some CAD software and start drawing. This CAD software, this video is on YouTube. Look for that video. And I know Graham said you use, which one do you use, Graham? This one? FreeCAD? Is that FreeCAD, isn't it? Yep. And so you can then download that for free, start drawing this stuff yourself. Now again, I'm not kidding you, talk to people like Graham and Norman, that you just find out, how big is this animal that I want to undertake? But if you chip away at it, it's like, how do you need an elephant? One bite at a time. All right? So if you really want to get into this and you just chip away at it, then you will get better. And you've got, and I don't want to throw these guys under the bus, but you've got some skill base here already that can help and assist. That's the best thing. Rather than hunting around on YouTube all the time for the best video to watch, it is helpful, but you've got also people here that can help you press. What's the next button to press? And if you do get that printer here, and an up-spec version, then you'll sort of want to get into it more and play a bit more, and that's how you build it. That's how you get your knowledge. But you will outgrow Thingiverse, and you'll go, I just want that hole. I found the right size disc, but I don't want the hole there. I want it over here. Well, you're going to have to draw it, or you're going to get it and print it and drill a new hole. All right, but it's amazing what you can do. But yeah, hunt around and have a look at this software. This breaks down all the different, what the softwares are capable of, what it can do. Also, say if you want to go commercial and you want to start selling a few little items, are you going to be limited because you've drawn it in this software? Some of the softwares allow that. They don't mind you doing that. So just have a watch the video and see if it's something that you can take on board. Next one, Tim. I'll introduce you to Joseph Prusa. He's the man who designed this, and I bought the printer off. He's in Czechoslovakia. He's a billionaire now. That's in his background. That's his print farm. That's printing. Some of these parts were injection molded and some were 3D printed. Injection molded, we all gone to Bunnings and bought ourselves a drill in a nice plastic box. That plastic box you bought your drill in was injection molded. And if you've got moisture in your plastics while you're injection molding, you're going to have similar problems to those photos that I showed you on the screen. So there can't be any moisture in that as well. But injection molding costs thousands. They have to build dies to make, and that would be that 3D printer would be injection molded, all the parts for it. Most of the plastics are still injection molded. There is a flaw within 3D printing in the way that, because of the layers, we've got delamination issues. I don't know if you remember back to the last, even in metals, I don't know if you remember back to the last Olympics, someone had handlebars on a push bike and they broke during a race because of delamination, because we've got this problem of separation. Even they run that through a sintering process and sort of run it through a heat afterwards and try and get it to fuse and bond better, there's still these issues. So some of these parts are 3D printed and some of them were injection molded. But this is the man, and he makes these machines. And I believe, I went to a talk with the Foundry Institute in 2019, and I went to Mob in Malaga, and they had a 3D print the same machine virtually running. And I said, look, I want to get into 3D printing. Why have you chosen this machine? I said, well, this is the gold standard for entry level for people who want to play, who want to get an affordable machine. I went to the Chinese one because I thought, she'd be right, I'll go to the Chinese one. I should have just gone straight to this and saved all the messing about, because the life is easier with this make and with this man. All right, he was playing with 3D printers when floppy disks were around. All right, he's progressed and moved. Next slide, Tim. Thanks. That's his print farm. So again, all these machines run just to would have expanded. He's just growing so much because of his new machines, and I'll show you those pictures in a minute. Yep, next one. Now we have, in Perth, we don't have direct access to Joseph Prusa, but we've got Tim Brookman and Alicia Brookman who own the Shape Shop in Belmont. I go to them for everything I need. Tim is of a similar age to, I would say, to Joseph Prusa. He also was playing with 3D printing in the days of floppy disks. He is the man in Perth, and his wife Alicia, she's no fool either. They're both very much a really good team. They run out of a little warehouse in Belmont behind, just off Belgravia Street. And he stocks the Prusa gear. If I was going to buy one, and I will be buying another one, I'm going straight to him, because if I've got problems, I get him to help me fix it. It's like everything. You got to buy somebody, you bought the machine off them. They're there to support you. They help you. Next one, Tim. Sorry, before you do, this, I don't know if I've got a really good image of it, but this is the Core 1. This is his new machine. It's like an enclosed, and I was talking to Norm about, or was it Graham, about the Bamboo Lab. And there's like a Bamboo Lab machine, which is a comparison type machine, which is a Chinese version, which is a lot cheaper, but you just go with Prusa, you would have for less problems, that's my belief. Next slide, mate. So that's their contact details. Tim and Alicia, both very helpful. Tim's a hard man to get off because of his skills and knowledge, everyone's after him all the time. So, but I would think if the men's shed wanted to do something, have a little chat with the people, with the group, this is what we want to achieve, this is what we want, then go to Tim with those, this is what we want, what do you advise? He's the man. I wouldn't want to advise you what machine to get. I don't know, like what he knows. He's the man. Next one. And that's the Core 1. So you're looking at $2.5 grand for that. That's one option. I'm tossing up with my next machine whether I buy this or the next one, Tim, which is the MK4. I haven't got such a good image. The MK4S, which is a little cheaper at 2K. If I buy the MMU, which is the MMU is like an interchange, so I can run about 6 different colours on the top, and it looks similar to this machine. It's just got so much more updated software and so forth. I can run different colours through it, and it will blend and match the colours and everything. This would have been printed using an MMU or something equivalent because of the different colours in it. Whereas I stick to one colour. Now that was your one, Tim. You can hand that one around so people can. That was printed as it came off the printer, just like that. This one came off the printer. I got this when I bought the machine. It was on the SD card. This is a fidget spinner. It came off the machine as it is. There was no assembly in this. It came straight off the machine like that. And then there's a couple of metal pieces here that Norm's got. I'll get.
Brian.
Sorry, I keep saying Norm. Sorry, Brian. That Brian's got, and I'll let Brian probably just explain a little bit on that. There's titanium pieces. I'll talk about that in a sec. Next one, Tim. So that's what you can get an enclosure for the MK4S, but then you're at the same sort of cost as the newer Core 1. You need to talk to professionals about that. But they are the two machines that I would suggest. Well, either one of those I'm going to buy next. And I would suggest that maybe for the men's shed, that would probably be the wisest option if you want to sort of move forward. So that's really that. Now, I'm going to open up, this is pretty much it. I'm going to open up for questions in a second. If anyone's got any questions, I'll do that in a minute. Brian, did you want to mention anything about these titanium? I can pass these around? Pass them around. These are titanium pleated metal pieces. And they were printed. Yeah?
They were, yes.
And how much? And they talk about the expense of a machine to produce a product like that.
About $285,000.
There you go. Yeah. So, yeah. So I don't know nothing about that. I've been to a place in Malaga that does it, and they're set up. They're just their heating process to try and fuse it all together at the end of the process, 100K, just to set up the oven, you know. So the question people ask me, and like I said, I'm a weekend warrior with this stuff. I'm not an expert, but people say to me, you know, what do you reckon? How long before metals will be 3D printed? And I don't know if it will. I think the improvement in the plastics will come before the metals get there. So I think the technology of plastics will get better, but will they ever overtake? I can't see it. This little groovy thing I made last night, I drew it up on CAD. It took me about 45 minutes to draw this last night. And the idea is that, and I've been wanting to do it for a while, there's like this wireless mic I got here. Here's the second one. I've got a magnet on the back, that's why I can keep it on my shirt. I put the magnet on the back, that little hole in the back, so I put the magnet on the back like this. And then I just slide the mic in. And then the magnet pulls it in, so it's pretty groovy. And then I just pull this out when I want to take it out, and then the magnet comes with it. Well, the practical side, the time it takes, yes, definitely. And that's a big issue.
Is that likely to improve the technology going?
Slightly is the fact that the new machines move a lot quicker than this.
Yeah.
These new ones are talking it, but at the same time you can't move too fast as you lose your fusion. Yeah. So always got that issue. I think where it's got the advantage of 3D printing is just the model concept. Like I said, how this engineering shop I went to, they use it for. They've got a little specific part they want for a component that it's like making a piece out of titanium. Just the cost of materials alone is going to cost you a fortune. So if you can then trial a piece and sit, does it fit, does it work, does it match, does it look okay? Okay, let's go make the real thing. So that's where a lot of people are using it for that. I use it for my trial bends, before I actually bend something on a press brake, if I've got complex bending going on, and it's useful.
So when you got, if you look at the difference between the Geko and the fine stuff.
Yes.
That's two different printing methods, right?
The little chest piece was a resin printer, yes.
Yeah, because that obviously gives you a finer resolution.
Yeah, yes.
And you'd have to use a resin printer for the what I call for the gear system, because by the look of it, that one gives you a much coarser finish.
Yeah, but.
Or can you fine tune it?
Well, my printer's getting a little on, so a lot of stuff I'm sitting around is looking a little bit tired because the printer's getting a bit tired.
Right.
But that little fidget spinner was created on the FDM on this.
Is it?
Yeah. So you get quite a fine finish. Just resin gives you like a glassy finish.
Yeah.
Sorry, who was the gentleman who brought this in again? What's your name again? Keith brought this in, and he got it from. There you go. The print's finished now. I'll talk about that in a sec. That was good timing. So this would have been printed pretty much. Keith can explain what it is, but it's for oh no, that would have been. I thought that was all fixed in, but some of these components. Say for that example here, this is a solid unit. There's an internal part in there, so it's like a filtration system for fish breeding that he uses, and that screws in the bottom. But inside there's an internal shaft inside there which has been machined, which has been printed as it's been constructed. So it's got an internal component in there, and that's sealed. That's come off the printer like that with these internal components that's in there. So this is what it allows you to do this type of thing, and it's quite. It's impressive. It's a nice clean finish on the print. It's a quality print. The whole thing's printed on the box and everything.
Yeah.
Yep.
And that the black thing on top there, that snaps off.
Yeah. Yep. And back to Brian's little jobby here. Come and have a look at this, and you can have it later, and you can have a look at the suspension underneath it. But again, here's the sample of the suspension. Fuel tanks. I'll let him explain it. But the turntable, that was all this PETG, PLA, TPU, the flexible stuff, the more basic stuff like what I used. Yep.
Can I ask a question?
Yeah.
Does the government, through TAFE, do they teach this sort of stuff? So how do young people that are going into a factory where they want to do 3D printing, are they learning this?
No, because we do it. I push to get machines similar to this in my department, in the fabrication department. The boss says, "What do you want?" I says, "Well, I don't really know yet." But we need it because we don't know what's coming. So we want to hit the ground running. So I think we need to start playing with it. While we're in the office, we're doing our stuff. Let's just have it go in the background. So we've got half a clue. Because if we start teaching CAD only, how much better is it to produce a model while you're drawing? Having said that, you've got a CAD class in for the 9. How long that took? 40 minutes. Not everyone's going to get to have a go, but at least they can see the concept and you can introduce it. I think the biggest question is, where will it be used in each trade? It's not a trade, because the kids go, I like 3D printing, yeah, but where's your practical? Well, get a trade first. Get some electrical skills, plumbing skills, fabrication, machining, whatever, and then start building on using the equipment like this to help you with your understanding. And you might think up ways where it can be used. It's still a bit of the unknown. you know, a practical situation, I think for a men's shed, you know, you want to build something, you want to hang something on a wall, a tool rack, you want to hang all your tools and mount them in a nice unique format, bang, you can create all of your little mounts on this, which you think, oh, what's the point of it just for that? But I think it's the knowledge that you're gaining as you progress, and it gets passed down as time as things evolves, as the sport of 3D printing grows. All right, this is what you will grow into, if that makes sense.
You just find various applications.
Yeah,
once you've
that's
got,
right.
Oh, we can do this now.
Yeah,
We can do that.
I mean, you know, you're like Tim's doing up his Tirana. You know, there's little parts of a dash you could print off to help hold a bezel or a gauge in position. Otherwise, you've got to make it manually out of metal and. Yep.
You mentioned the tool rack. Let's say it's, I don't know, 2 foot long.
The what? Sorry, the tool rack. Yeah.
Yeah, tool rack. Let's say it's 2 feet long,
Yeah,
right, or whatever.
Yep.
Would this thing printed obviously the
You do it in
places?
stages,
Okay.
and this is where you need your CAD drawing. Having said that, go to Thingiverse and you'll find a hammer holder or something, you know, ball peen hammer holder or a claw hammer holder. But you know, you're always going to want to have your own custom look, and so, or custom sort of fit how you want your tools to. There's ways that you can actually print. You could, once your CAD drawing gets good, you can actually draw it, say, a part, a component. You have holes in it, and the end of it. A guy at work does this, where he makes the holes at 1.8 millimetres in diameter, cuts off a bit of filament, feeds the filament through the little different holes that match up, and then he JB weld is the plastic glue they use, puts that in there, and he builds things in like that. There's another third, I don't know if anyone is familiar with nutsert tools inside metal and timber and that sort of stuff. There's ones you can get for 3D printing where you just put on a soldering iron, you just stamp them in, pressed into the plastic so you can screw things together. But again, you're going to need more advanced CAD skills to get that to happen.
Is that dependent on
So-
sorry?
Go.
At what stage do you have to start using the strings, the support strings? Like
The support material, you mean, those support like I talked about, that support stuff?
Yeah, like on the small boat there. You know, would you have used support strings?
This one, the idea of this one, you want it to collapse if you had your settings wrong. You don't want support holding up. The whole idea of this test print is that you want to see, oh, that arc, it's pushing the limits. So then you can test it that I didn't need to have support.
And it would have cooled down
Yes.
at that time anyway.
Well, yeah, but if it's got nothing to, if it hasn't got that support, it's going to collapse. If it hasn't got the support underneath.
Okay.
So, and that's where this idea of this little arc in the front of that bow, it pushes the limits of what the printing's capable of. There's certain angles that are in people's heads that I know I'm safe at 45, but as soon as I go over, I'm in dangerous turf. I'm probably going to need support to that level. And you always try and aim for no support if you can.
But you have to decide that before.
No, your slicer will tell you.
Oh, you can.
You can choose your slicer, no, it's not going to work. Change it all. Okay, that looks like it's going to work.
Yeah, right.
But even then, you still have a few little errors and tweaks and adjustments that you have to make. Yep.
Those strings go down with.
Yeah, they come from the build plate. So, for example, before I pull this one off, have a look at the supports on that, under his mouth.
Supports on his face there.
You can see under.
Oh, you still
Underneath
using
there,
that?
all that supports.
Oh, wow.
So, have a look at that. I'll just send it down this way and you guys can send it up. But have a look under his mouth and you can see the support doing its job there, because otherwise his mouth has just got nothing to hold it up. He's just going to collapse. All right?
But did you actually
I've got to go back to that in a
put that
minute.
into the pattern, or did
I
you just
told
use
Prusa, I told the slicer, supports please. I can change different types of supports in there.
Right.
There's the organic supports that look like little tree branches growing off of my. Then I built this one. This one's called a grid support. This one we used an organic support, it was cool. You can see how these little different levels and layers take a little bit to get your head around. Sorry, and we'll jump back to that question.
A question about bed size. So
Yes.
that's a limitation on. So is that a commercial step up?
Yeah, the bed size relates really. So most beds standard about this size, 200. So the build volume here on the X and Y, 200, 200. The Z is 200. Prusa make an XL, which I can't remember what the boundary is, but that's like this size machine. And it's got the MMU where you got all your different filaments if you want in it. And I wouldn't necessarily call it commercial, but you would probably perhaps use it more for commercial. Excuse me. But some people into figurines, like a lot of these kids are into, Iron Man. They want the Iron Man mask or whatever it might be and all this sort of stuff. You're going to need a big volume for that, and it can do that. So some people who, this is their life, 3D printing, and they just make these, figurines and stuff, and they make whole Star Wars models about this tool, and they've done it all in stages and sort of screwed it all together, what they've done. So really, I would still put that Prusa XL stuff into sort of a lower, but a really guy who's really into his 3D printing. If you walk in the workshop in the door of, if you ever go to see Jib and Alicia over there in Belmont, they've got a machine, they call it a Prusa machine. This thing's worth 30k. And its build volume's only like this, but it's about this tall, and they can really get, and they can go, and it's got a really sensitive chamber inside where you can really control your environment. And those, and show you one thing I didn't talk about, those printers, like this chamber here, this is an add-on for the MK4. The MK4 is the next level up from this one, this machine which I'm looking at, or the Core 1, which is that other one with the other enclosure. In that enclosed, remember I said oxygen's the enemy in welding, and it's also the moisture, the problem, those coming into the space of 3D printing. You can control that so much more with the chamber. You can stop that. I've found that even though I'm playing with PLA and PETG, I've got delamination issues in winter. If I'm in my workshop in my shed and I put it there, and that separate layers move because the cooler atmosphere that I'm trying to print in. If I'm inside a chamber, I just got more control, even if I'm only playing with PLA and PETG. But if I go into more advanced plastics, I'm going to need a chamber. But for PLA and PETG, you can pretty much get away with it.
And I presume wood dust is a contaminant as well?
Oh, I would imagine. Yeah.
Just adds to the ambience of the product you make. If you wanted to do 6 of those.
6? Yeah. Of the...
Yeah. 6 on the one plate.
Yeah, definitely. I didn't mention that. It's a good one to point out.
Yeah, because that one just came out in the middle. So
correct.
You have to take it off and start again.
That's right. Yeah. To keep it simple, I just did the one. But definitely, you could choose how many you can fit onto the build plate. You can print. A lot of them I printed, I think, 8 at a time. All I do is press copy, and this is all done in Slicer software again. Copy, paste, copy, paste, copy, paste, regroup, poof. And then I look, and I don't like the look of that position, so I might just twist a few of them around just to get them to match up a bit better. Yep.
So a lot of the 3D in plastic, very good. My background in mining would be used a lot. Proof of concept, when they want to come up with certain parts, to assist with their work.
Yeah.
But like, let's say if you went to UWA or you went to a commercial place where you can 3D print metal, the engineering aspect, would that be complicated? Because,
Well, look at the cost that Brian was talking about for that. Imagine machine shop, you've got a block of titanium and build a new machine out of that.
Yeah.
You're still ahead with that, I think. Yep. Because you've got a structure more sound. You haven't got a flawed product that isn't proven, like those layers issues.
Yep.
So, as I said, the metals I don't think are there yet. Will they ever get there? I don't know. And there's a lot of people invested into it thinking it's going to get there, and I don't know. But it's out of my pay grade. Yep. My mate is the fabrication supervisor at Welding, and they use it for little control boxes for the operating of their drill equipment. But they wouldn't use just PLAs, and they've got an expensive printer. And they'd be using sort of other plastics that I don't know anything about, but are more structurally capable. But they do 3D print parts successfully, but it's a control box. It's not like a moving, it's not under high dynamically loaded or anything. It's just static loaded, It's not under any stress. Yeah. Another thing in the MK4, the technology that's come with the MK4, I don't know if any of you used to using a crane and you get this swing happening in a workshop. We use a lot of cranes in workshops where the pendant sits still, but then the load's moving. Imagine the load moving under a pendant that's still, and you can move the pendant to try and knock the movement out of the chains to settle them. The MK4S, it's called Shapeshift, and that, I think I'm on the right track with what it's called, and that actually takes the swing out of the issue in the print, and it just, everything moves. That's why it can move so much faster. So that gives you better, quicker results and more stable results because of that newer technology. And this is the things that adds to the changes as well in this game.
I think also is the filament is slightly offset each layer.
Right.
So you don't actually have it one on top
Yeah.
of the other.
And you can change that in the Gcode. I've been meaning to investigate that more because you've got a weak spot, haven't you?
Yes.
One thing I did here in this little thing I made, so my battery supply for my camera, I just printed this off. So, but notice when I print, and my printer was running rough at the time, you can see the layers really stand out and see how they're like that, bang, bang. If I printed it like that, I would then have layers moving like that, which would give me a more structurally capable, because imagine if I keep pulling this, and if I've got those layers running the same way, that's going to separate over time. If I put it at 45 or change the angle, I'm going to have just a stronger product. I'm experimenting and playing with bits of stainless steel round bar, so I leave a hole in there, I'll run a round bar in after the print, and I'll just let it sit in there and lock in position. It gives more, if I need it, it gives me a bit more structural strength to whatever it is I've made, you know. I'm just playing with stuff like that. Yep.
Do you reckon they'll move to, so your build boards could be pivoted, so like you've got an axis on your build board?
What do you mean, sorry?
Oh, so like, let's say you're printing and you want a different angle, so your actual build board would pivot. So
a lot of movement.
Yeah.
You would slow things down a lot too if you did.
Yeah.
I think you could achieve that perhaps in how you angle it as well in your Gcode before you set up your position of your actual product.
Yeah.
But as a CAD designer, as the person who's designing this, what I'm finding is if thinking about all that sort of stuff affects my design. I'm only printing this in solid pieces. I actually want to be, the next step for me is going printing that separate, in separate pieces, and be able to bring them all together into one model. I can't do that yet. They're all parts that you have to align, and I haven't got to that stage yet. But like everything, you just get better at it. Yep. So that's pretty much it, guys. I'll take that, once finish having a look, by all means finish having a look, and then I'll pull that off the board and I'll show you what that process is like. But come and have a look at Brian's truck here later and have a look underneath it and his suspension, what he's done. It's pretty cool. And there's other bits and pieces that he's got here. And talk to him about his TPUs and his other, remember I'm playing with PLA and PETG here, the basic filaments. But he's been playing with other, and also have a look at what Graham's done with the Flash Forge, what he's done, he's got that up and running. But again, a manual machine, you have to sort of go back in time again a bit there to be able to play with that and put that energy and effort into it. But most people wouldn't be interested in going backwards, they want to go forwards. But it's, like I said, it does teach you a lot though. But that's roughly the idea of it.
Yeah, if you use, let's say, silicon oil, right, for that, would it affect the first layer of the plastic or second layer?
Depends on what you're printing with as well. Some plastics, see I use that isopropyl alcohol, gets rid of any oils off the surface.
Oh, right.
But then other ones I've talked to, when I'm going into, say, nylons or I won't use, I can't remember what it was, I was asking it, and Alicia helped me with this at the shape shop. I said, what do I use when I print with this one? She goes, get a bit of sweat off your forehead, rub that over the surface of the plate, and that'll just help you with pulling it off. I go, right, good to know, thanks. So depending on the plastic you're using, and this is where it's so much better having someone locally, because I buy my filament through them as well. If I've got a new filament, I go, what advice would you give me for printing with this filament now? And they're just so good, these guys. They just tell you everything you need to know, and it's you're not hunting around, spending half your night on YouTube one night, watching your life pack, pass by. You got them on speed dial. That's what I would suggest.
Sorry if you've covered it, but is there any multicolours?
Yeah, no, that was cool. That's a good question.
Thanks, Glenn.
Yeah, no, thank you, mate. The MMU, Tim, you go back a couple of slides. Maybe one. Yeah. That little product here, it sits on the gantry here, and it's quite complex because you'd have a box, another shelf with a box with different filaments in it. And they've got a drying thing inside it, like you'd have the gel packs and that sort of stuff. And they come out and they run through that MMU, and the MMU through the Gcode will be, you work this out in the slicer, and it'll tell you where it wants. I want, say for Brian's truck, I want red wheels, I want black tyres, I want a yellow fuel tank. So you can program that in to into your slicer software, and then the Gcode will read it, because everything, once you've put it into that slicer software and produces the Gcode, all that information you've programmed is on that Gcode, you put it in, and then the MMU interchange will make up its mind for you, and it'll do it all for you.
Multi-drums,
Yeah,
different colours.
about 6 I think it is. I think it's 6. Yeah, that's it. Righty guys, we're good? No worries. All good.
Thanks for coming, Glenn. I think it was very interesting.
No worries, Andy. Anytime.
So I can see when computers are no longer being recycled, we'll have printing stuff making teeth.
Oh, yeah.